Hello, I am Nicholas Turrell, from Airbus Airframe Customer Services. This tutorial will explain you the basics of SRM for mechanics application, how to download it, and make it ready to start a damage assessment, and what are the keys to use it, based on a few examples. I am sharing here the screen of an iPad running on iOS. All what will be shown in this tutorial is equally applicable to any mobile devices powered by Android. Let's first see how to download the mobile application. I can open the App Store here by tapping on the top left icon of the screen. I search for SRM for Mechanics Official, and tap on the icon to download it. Once the application is installed on the mobile device, I can launch it, and accept the notifications. Before I can perform any damage assessment, I have to download a package, which corresponds to the technical content of the SRM. I tap on the bottom right button to view the packages installed. The download of any package requires the signature of a service agreement with Airbus. You can find more information on the Airbus Services Store, or by contacting your customer support director. I tap on the Refresh Packages button to connect to Airbus World thanks to my account. I can now see the available packages that I can download by tapping on the Install button. It is required that the Airbus World account is granted with downloader rights. Please contact your Tech Data administrator if you cannot install a package. I go back to the Start screen, having downloaded a package for the A320CO Standard 1. The setup is complete, and I do not need any more Wi-Fi or internet connection. The application can now work offline. I am now ready to start a damage assessment for an aircraft part of the package installed. I first read carefully all information displayed on this screen, and tap the Start button. I am invited to select the unit of measurement, either inch for the imperial system, or millimeter for the metric system. And I tap on the Next button to go to the next screen. The content of the damage assessment displayed in the app is customized based on the aircraft selection. So, a proper aircraft selection is required to get a valid damage assessment. I can select an aircraft by registration number, or by MSN in the aircraft family. For the tutorial, I will use a fake aircraft registered Airbus, and I can find it from its MSN as well. Once the aircraft is selected, I tap on Next to go to next screen. In each screen, the Next button will be activated once the required selection or data input is made. I can select the damaged component, either in ATA 52 for doors, 53 for fuselage, 55 for stabilizers and 57 for wings. And in each component, I can find a selection of damaged parts supported by an illustration to ease the understanding of the location. I scroll down to view the complete list of damaged parts. And, if the part on which I have a damage is not available in the list, I should refer to the SRM in AirNavX. Depending on the screen size of the mobile device, the illustration may appear small. I can tap on the magnifying glass on the top right of the illustration, pinch with 2 fingers to adjust zoom, and slide to move around and see the details. When I have seen all I need, I can tap on Close to come back. Let's take as an example a dent on a fuselage in the forward section. The damage type selection may vary from one damaged part to another, and may include dent, lightning strike or rework. Pay attention to the warning and caution displayed before making the damage type selection, and refer to SRM if your damage type is not in the list. For the example, I select dent and tap on Next. From this step, the assessment is driven by the technical content of the corresponding SRM task. I can read the questions and answer based on the damage information in the same way I would do when using the SRM on a laptop. Some questions are supported by illustrations when relevant, to ease the understanding. For others, I can tap in the input fields to pop up a keyboard. The app will tell if the data is of proper type, such as decimal value or string, when tapping the Next button. If wrong, I can correct and continue. I enter all the data corresponding to my damage, step by step, up to the display of an intermediate summary. I can scroll to check all inputs entered in the previous screens. Here, I immediately spot that the value for the Y dimension is not correct. I can go back to the corresponding screen by tapping on the back button, correct the value, and proceed again to the summary. Now all is correct and I can continue the assessment by selecting the panel as per the illustration displayed. On this screen, identifying the stiffening elements may not be an easy task, so I tap on the magnifying glass to zoom in. Thanks to the vertical and horizontal bar on the top right of the screen, I can materialize lines to locate the bay where my damage is, and scroll to identify the proper frame and string references. In this case, between FR28 and 29 and STGR21 to STGR22, LHS. I enter this information as free text and continue by tapping on the next button. The selection of the zone where the damage is located is supported by an illustration, the applicability mapping that is in the SRM. In this case, the damage is located in the green zone with 45 degrees hatching, corresponding to Zone 1. I scroll down on the next screen to see the question asking for the thickness of the panel. Searching for the right illustration, zooming to identify proper frame and stringer references, which correspond to the letter code B, which leads to a thickness of 1.4 mm. As I have only one thickness zone impacted, I enter the same value in both input fields. I can check again the data in an intermediate summary. Here everything is fine, so I can continue. And only a few minutes after the start of the assessment, I get a result. Here, good news, with the damage being covered by SRM. I can find the same information as in the SRM, with the repair action, the repair solution, the repair category and the life limit. At the bottom of this result, I can find information on the diagnostic date, the SRM revision, the SRM for mechanics revision, and the reference to the SRM task supporting the damage assessment. Going to the next screen led me to a full damage report, which includes the data processed in the app during the assessment, such as the aircraft information, the damage summary, the damage location summary, the relevant damaged zone, and the result. I can now tap on the Save Report button to both save the report in the local storage of the mobile device, and share it by email or any other communication means available on the mobile device. And I can restart the diagnostic for another damage assessment. Let's start now a damage assessment on a different component. Selecting the same aircraft, and searching for a lightning strike damage on the sharklet wingtip structure. I answer the different questions in the same way as the previous example, and enter the damage dimensions. I check the inputs in the intermediate summary, all good. And I get the result, which in this case is a no-go with the damage being outside of allowable damage limits. Not a good news. But at least I get the result quite fast. And even if the app is not covering all damaged components, damaged parts and damage types, it should cover many of the typical damages in operations. If not, it will take only few minutes to realize it, so it is worth trying. The next part of the assessment drives me through a set of questions to complement the damage report. I can take pictures that I will be able to send along with the damage report generated by the app, and advise on different actions that I have performed, support needed as free text. I finally reached to the final report, in which I can identify very easily the parameter that fails the coverage by SRM thanks to red cross and red text. I save the report in the files, and can restart diagnostic for another damage assessment. Let me show you now where you can find the reports generated. When you open the Files Management on the local storage, you will find a folder structure under the name SRM for Mechanics, and inside a subfolder for the reports. The reports are stored in both PDF and XML formats for eventual customization in a maintenance information system. The PDF version has the same look and feel as the one displayed in the app. If you encounter some app issues, another folder may be created to gather log files that may be useful if you contact Airbus via tech request. I hope you have enjoyed this tutorial. Don't hesitate to contact us for further information. Thank you for your attention.